items that we will use for testing our board and the system as a whole. We have also gone and created a preliminary labor cost, and this is based on 4 engineers working an approximately 25-hour per week schedule for the duration of the project, which is 16 weeks. That brings our hours to 1,600 hours estimated at a rate of $30 per hour, which gives us $48,000 for labor costs. Once you add in our workspace rental fees that we estimate at around $1,100 per month, this brings our project total to just over $65,000. Now I'd like to turn over to Brad Swallow.
Thank you, Brian. What we have shown here is a broad overview of how our team has been assembled. As you can see, each of us has our own set of expertise. However, these also overlap, so we can assist one another when and if we have problems. Now for just a quick overview of the qualifications of each member of our team. First, we have Joey Filippi. He's our project manager. He has 2 years of managerial experience. He has extensive knowledge in software, including programming languages such as C, Java, and several others. He has been trained to use the Flex tester, and he also has 4 years of logo and animation design. And next we'll move on to Brian Roby. He is our hardware engineer. Brian has 1 year experience of automation as well as control systems. He has 2 years experience using various sensors as well as filtering. 3 years experience of general hardware design and applications. And he also has 2 years experience of general communications networking. As for Alex, he is our software engineer. Alex has 4 years of hardware development and design, 3 years of software design as well as embedded system design. And he has also been trained on the Flex semiconductor test. And finally, as for me, I'm the testing engineer. I have extensive knowledge in both hardware and software design as well as testing. I'm the webmaster for our group, design websites for both personal and professional use. And I also contain several years of leadership and management experience. And now on to our technical merit. This chart basically goes over all of the technical aspects of our project and makes us realize how complex some of these aspects actually are. First, as we went through and mapped out this project, we found that this project does indeed have, and we understand, a clear technical challenge. There will be a requirement for system integration. We will be communicating to the SCADA pack via Modbus, as well as incorporating SIGCOM, the compressor control software we talked about earlier. As for testing, we will be designing a test plan and implementing it to ensure that our prototype is fully functional. And we will also be contacting the Petroleum Engineering Department at Texas A&M University to see what further tests they might recommend. As for analysis, this is a fairly big portion of our project. We'll be taking in data from various sensors, strain, temperature, etc. And we'll be analyzing the information, and then deciding, this will ultimately decide whether or not to slow down, speed up, or ultimately turn off the pump jack. As for hardware design, we will initially design a circuit for our product, several circuits, and eventually leading into our I/O board, which will contain the variable speed drive, which will control the motor at the pump jack. For software design, we'll take all the initial steps, flowchart, pseudocode, until we get into our final product, the final source code, which controls our product, or our prototype, sorry. And we will also be developing a graphic user interface for the technician's laptop, as well as an HMI to be used directly in the field on the side of the pump jack. Fabrication, we will be creating an enclosure that will house all the inner workings of our prototype. And as for the last two, the documentation, our publication, and the intellectual property, we decided not to include those at this time. As our project progresses, we may choose to change that at a later date. But when we add this up, we got a total of 1.5 for our technical merit, and we feel that that is sufficient for our project. That's all we have for today. We thank you guys very much for coming, and we would like to open the floor for questions at this time.
Functional diagram. On CPAC LDC, it's Bluetooth and wireless.
Yes.
Is there two different ones? or-
Yes. The Bluetooth will be used to connect to a technician's laptop locally. The wireless communication is already in place, used to connect back to the SCADA host. It's just sending radio radios.
Back to the central host.
Which stage stand?
Signal, control, acquisition, data administrator.
They're building a board. I understand what it says, but I don't think it's on there. While we're here, can you give me an idea of how you're going to be able to simulate the environment, or are you planning on bringing one of these pump jacks here to your lab so that you can run it?
Honestly, through the course of this project, we're going to have to go out to the field and for in here, we're going to be testing with the motor. We're going to have that provided to us by EnerSys and several of the sensors that they have. They're also going to provide us with data from oil fields out in Canada. And then whenever we finally integrate this, we can either go to the petroleum engineering department and seeing if they have any instruments that we can use, or just take it out to the oil field down in Alvin.
Okay. And help me out here, because I'm not sure, even though you have this color coded, what colors are you providing versus what's already provided? Just
Okay, and in terms of this, we're providing the dark blue area. Some of that overlaps with what's being provided to us with the light blue. Any of the red is units that we're going to have to program, just providing our software. And then pink SCADA pack that represents just SCADA already has information that EnerSys uses on it for communicating back to the host, and we will be partially programming it to store data.
okay. You're gonna. What hardware are you designing?
Hardware that we're designing is the I/O board.
So you are going to select a PIC processor, you're
Correct.
going to be selecting onboard indicators, you're going to be doing signal conditioning.
Yes. And then through that signal conditioning, we're going to analyze just all the.
But on
sensors
your
that-
board, you're going to have everything that deals with SIGCOM?
Yes, it's going to incorporate SIGCOM as well onto the system. And basically, we're just going to be combining their schematic with our creation on the schematic. Because what EnerSys wants to do is just be able to market this system together as one system, so that they can just say, hey, we're selling you this in one enclosure. It has all these features to it, and you can either use it in controlling your beam pump or your compressors out in the oil fields.
Okay.